The Hele Shaw is a visualization technique where fluid is confined between two planes separated by a small gap. With this setup, laminar two-dimensional flow is visualized around different shape models. In this case, we have assembled two pieces of plexiglass separated by approximately 0.5 mm, with a small inclination angle and a reservoir of water and dye upstream. By putting an object in between the planes, the Stokes flow around it can be seen. From the theory, it can be shown that this flow is governed by a Laplace equation, which is also the case for potential flow, which is characterized by being irrotational. This means that this setup can also visualize two-dimensional potential flows, and also that the strict lines that we see are irrotational, which implies that we don't expect phenomena such as boundary layer separation around the objects. Through different tries, we found out that the biggest obstacle to create this flow is dealing with the air bubbles trapped around the objects. To solve this, we decided to reduce the surface tension of the fluid by applying a small amount of soap to the water. This facilitates considerably the experiment and also introduces small soap bubbles into the flow, which can allow a qualitative form of particle tracking. By looking at the bubbles, it can be checked that the zones of the flow with the highest curvature for the strict lines are the zones with the highest velocity. As shown here, particles accelerate when they are in a curve and decelerate when the strict lines are straight again. In addition, by looking at how the strict lines are perturbed by the object, we get an idea of the forces that are acting on it. With this in mind, we can check if, for example, the geometry at a given angle of attack can or not produce lift. This simple demonstration can be useful to illustrate basic concepts in fluid mechanics, and also to test simplified models. For more information, we recommend reading the relevant literature, such as the chapter on laminar flow of the book Fluid Mechanics by Kundu, reference listed in the description of the video.